Thank you for volunteering to the Lower Great Miami River Water Quality Lab. I'm Sarah Meadows, Public Involvement Coordinator with the Hamilton County Soil and Water Conservation District, coming to you from the Great Miami River. We work closely with Rivers Unlimited to get this lab certified as Level 2 through the Credible Data Program. This means our data from the lab can be used at the state level by Ohio EPA, the county level by the Soil and Water Conservation District, by local nonprofits such as Rivers Unlimited, and others. This data can be used for regulatory purposes to identify red flags that help prioritize projects and other watershed planning purposes. For this reason, it's important that you follow the procedures outlined in this video. For example, every 10th sample will be a duplicate to ensure there are no errors along the way. If this is confusing, don't worry. There will be at least 2 lab managers on site during every sampling day. Mike Miller is the program manager, Lisa Lee is the lab manager, and Bernie Moeller is the quality control officer. Thanks for watching. Enjoy your video.
Hi, I'm Adam at Hamilton County Soil and Water Conservation District, and this is the Total Phosphorus Analysis Station.
Major sources of elevated phosphorus levels in our local waterways include treated effluent from wastewater treatment plants, as well as untreated discharges from sewer overflows and home septic systems that aren't functioning properly. Other important sources include fertilizers applied to agricultural fields and lawns, and the sediment resulting from excessive stream bank erosion and earth-disturbing activities such as site development. While phosphorus is an essential element of life, its presence in excess in our creeks and rivers can lead to harmful algal blooms and/or dissolved oxygen levels below that required by many species of local aquatic wildlife.
So when you come into the lab, our equipment will be set up a little bit like this. So let's have a quick introduction to what we have here. So this is our Hawk Method 8190 kit. And everything that we do is based on this. So it all comes out of this box here, and the box includes a couple of powder packets, a couple of bottles. One's deionized water, the other is a buffer solution, and some test tubes. So each test tube comes with a little bit of acid already in the bottom. So there should be some liquid in it when you pull it out of the box. Some of the other equipment we have here, this is our sample bottle that a volunteer has brought us from a local stream. Just a bottle of deionized water to rinse things off with. These are pipettes, and we'll demonstrate how to use these in a little bit, but these are for drawing up samples and solutions and squirting them into the tube. This is an incubator, which is perhaps just a fancy name for a heater, right? We've got some chem wipes here. We've got a photospectrometer here, which is going to measure the amount of phosphorus in each tube, and just a laptop with an Excel spreadsheet where we're going to record the data. When you come into the lab, if any of these things seem to be missing or out of place, or you have any questions at all, just ask one of the lab managers. Now let's take a closer look at the process. So we run our phosphorus analysis in batches of 25. So we have 25 tubes per rack, and the reason for that is simply because there's 25 slots in our incubator. So we start off at the beginning of each batch by getting 25 tubes in the rack, and then we'll just one by one bring in the sample and start squirting them into the tubes. Now it's important to remember to set up your duplicates and your spikes as you do the rack. So we're going to have a duplicate and a spike. We have to have it for 10% of our sample. So we'll have one on the first sample, and then every 10 samples after that. So we'll have one on the 10th sample, and the 20th sample, and the 30th sample, and so on. So when we get our first sample and we write sample 1 on it to correspond with the number on the sample bottle that it brings us, we're going to put 5 milliliters of sample into that. So we note that we have 3 different pipettes here. One is for 5 milliliters. So we're going to take 5 milliliters of sample, put it in the first. Now directly after one, we're going to have 1 dupe, and we signify that by just putting a dot after it. So we have 1 dot written on the lid here. And so there's no need to change your pipette tip from this one, since it's coming out of the same sample. But do make sure to put the lid back on your sample between them and shake them up so that we get a good mixed sample for each tube. So for the second duplicate sample, we're going to do 5 more milliliters of sample into that tube. And then on the third tube, this is our spike. Again, we're drawing sample out of the bottle here and putting it in. But this time, we only want 4 milliliters of sample. So we have a different pipette for this that's calibrated to 4 milliliters. So again, because this is the same sample, we can just use the same pipette tip. So we'll take it off the 5 milliliter pipetter and put it on the 4 milliliter pipetter. And we can then transfer the sample into the third tube. And after we get those 3 out of the way, then we can move on to sample 2, sample 3, sample 4, and just keep going in order until we get to 10. And then we need to remember to do our duplicates and our spikes. So the method we're going to be following is Hach's total phosphorus method 8190. And it comes in this kit here, like I mentioned. And just to show how simple this is, we're simply following a few steps with pictures. And so we'll have the pictures on the screen to guide you through the process through the rest of the video. But to take a closer look inside the Hach kit, we have 2 different types of powder. And it's really important to read what we have here because they look exactly alike, right? We have a potassium persulfate, and one says phosphate reagent. And so it's important to be using the right one at the right time. Also note that there's 2 different bottles in there. There's the sodium hydroxide buffer, and then one's just a DI water. And we won't be using that. In the lab, we'll usually have bottles of DI available for you to use. So under the hood, how this really works is pretty simple. We have various types of phosphorus that might be locked up in the water in organic and inorganic forms. And so we want to get this all into one form that we can measure with our machine here. And so the idea is that we're going to digest the phosphorus in this water so that it's all in inorganic forms. And so we've got a little acid in the bottom of the vial. We're going to put in the sample. We're going to add the potassium persulfate, and then we're going to heat it up, right? So the acid plus the persulfate plus heating it up is going to digest it, and then we'll have all of our phosphorus in one form that can be easily measured. So the first steps are going to be to turn on our equipment. So we're going to start up our incubator. We're going to start up our photospectrometer, and we're going to fire up our laptop. Okay, now we're going to pipette some water sample into a tube. So let's remove the cap on our first sample tube. Remove the cap on our sample. Oop, very important, I almost forgot. I'm glad I did, because it's very important that we shake these samples up every time we draw some. There's lots of phosphorus bound to the fine sediment in here. And so we want to measure it all. So let's shake it vigorously every time before we draw a sample. Now, before we grab a pipette tip out of the bag, and we take our DI sample and we just spray the outside of it off. And inside as well. Now, in addition to spraying it off, we're also going to pull and then throw away 3 pipette loads of sample before we load the sample into the tube. You want to get a nice firm fit here, and on a pipette, you move it down and then you let it back up slowly to draw the sample back in there. So you're sucking it back in. And then when you want to spit it out, you push it back down again, and then you can push it back down a little bit extra. You can feel a little click there. And that helps to blow out, any extra droplets that are sitting in the bottom of the pipette tip. So push it down until I meet that resistance. Draw it up slowly and smoothly. Then I waste it out and extra push. And I'll do that 2 more times. And now I can draw my sample. There you go. And next we're going to add our potassium persulfate powder packet. And the first thing you want to do is you want to hold it right side up and give it a few good flicks and get all that powder down to the bottom of the packet. Now the packet has a little blue line that says tear here. I recommend cutting a little bit below that. Sometimes you don't. It might not. It might not open if you don't cut a little bit below that. So you cut the top off, you kind of crease it open like that, and you just pour it in the tube. I like to hold it over a garbage can for this. And you shouldn't have trouble getting most of it out. We don't need to work for 10 minutes to get every last granule out of here. That kind of level of error is built into the method. So now we're going to put the lid back on, and we're going to shake it to mix up the powder, and we're going to do that until the powder is completely dissolved. It shouldn't take too long for this one. And that's looking pretty good. So once we have our potassium persulfate in, it's ready to get cooked in the digester for 30 minutes at 150 degrees Celsius. So we put it in and we press start. And now we wait for 30 minutes. Once the timer on our digester's gone off, we're ready to pull these samples out. Now the samples are going to be a little bit hot, right? So you can have gloves to pull them out and protect your hands. I find that if I just pull them out pretty quickly, it doesn't. I don't burn myself. So, but we do want to cool the vials or the tubes off before we work with them any further. And so we fill this tub up with water and just give it a little bath, just until it's cool enough to handle. So once your tubes have cooled down enough to handle them, we can go ahead and add our sodium hydroxide buffer. So recall that when we pulled our tubes out of the hot kit, they had a little bit of acid in the bottom. And so that was there to help digest the phosphorus when we added the persulfate and heated it. But now that process is over. So we're going to add this basic solution to help bring the pH back up to a more neutral level. So we're going to pick a different pipetter this time. This one is set to 2 milliliters as opposed to 5 milliliters that we used to draw the sample. So we'll take our bottle here. Remove the lid from our test tube. And we can draw up a practice run just to get the inside of the pipette tip wet, and we can spit it right back down into the bottle. And then draw our final one. And dispense it into the tube. Now we're going to invert this thing 3 times to mix it. Now at this point, some of our samples are going to get pre-read using the photospectrometer, and some of our samples aren't. And so the way that we do it is if the turbidity of the sample is greater than 50 NTU, then we're going to do a pre-read. And so you'll simply walk over to our friends at the turbidity station and ask them what the turbidity measurement was for that sample. But we'll pretend that this one was above 50. So now that we've shaken it up, we're ready to do a pre-read. And so we come over here to the photospectrometer, we open it up, and we simply stick it down into the hole and press read. But it's really important because this thing is measuring how blue, basically, the solution is, because our next reagent is going to turn the phosphorus blue. So any fingerprints on the tube can interfere with those measurements. So we're going to just wipe this off real good with a Kin wipe before we start. Insert and press read. And once we get our measurement, we just come over here and enter that into the appropriate location on our spreadsheet. And now that we've pre-read to correct for any effect that the turbidity of the sample might have on our photospectrometer reading, we can go to the final step where we add our phosphate reagent, which is going to turn all the phosphorus blue in the tube so that we can get a final measurement of how much phosphorus is in the sample. So, just like the potassium persulfate, we're gonna take the packet, we're gonna flick it to get all the powder to the bottom. We're gonna cut it just below that blue line. Probably should have pulled the cap off the tube first. Then just squeeze the packet open and pour it in. Now the reagent is going to take quite a bit more shaking to get it to dissolve than the potassium persulfate did. So we're going to follow what the method tells us to do, and that is to invert it 20 to 30 times. So I always do 25 just to split the difference there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Now, once you've shaken your test tube 25 times, we need to set a timer for 2 minutes. So you can't take your measurement until 2 minutes have passed, but you need to take your measurement within 8 minutes after you're done shaking. Just because that's the time frame where the chemical reaction is optimal for getting an accurate reading of the amount of phosphorus in the sample. So we'll put this aside, we'll wait for 2 minutes, and then we'll put it in the photospectrometer. And now that 2 minutes has passed, the moment we've all been waiting for, let's measure how much phosphorus is in this tube. Don't forget to wipe your fingerprints off the tube. Insert it and press read. All right, we have our reading. And now we simply go to the correct location on the spreadsheet, enter the reading, and we're done. Always press save. And now that we've finished measuring the phosphorus in the tube, we want to make sure that we dispose of the liquid inside correctly, because there are some chemicals in here that could be hazardous to the environment. So make sure to pour the liquid into a container that can be properly disposed of, and then we'll just throw the tube into the garbage.
Hi again. Hopefully by now you're getting excited for the sampling season to start. Remember, we sample on second Saturdays from March through November. Samples collected should be turned into the lab no later than 11 a.m. Volunteers for processing should arrive around 10. If for some reason you can't come in or collect your samples, please contact Lisa Link and we'll find a substitute for you. Thanks again, and we look forward to a great sampling season.